What does why it means? A system A is hot, or I can say a system is cold. Generally, we can, in the terms of physics, we are saying that a system A is hot if system A's molecule possess more kinetic energy than the system B's molecule. And if we make contact between them, let's say initially system A contains tons of kinetic energy that makes its temperature 20 degrees centigrade, and system B's temperature is 10 degrees centigrade, and at the point of making contact between them the time is 0, and after the equilibrium reach, let's say after t time, they achieves equilibrium. That means at the point of equilibrium you won't be able to make difference between system A and B in terms of temperature. That means both of them will have the same temperature, that is 15 degrees centigrade. It is clear that I am saying about thermal equilibrium. And Zeroth law basically is saying that two systems are in thermal equilibrium which a third system separately are in thermal equilibrium with each other. That means, let's say a system A and another system is B are separated by a wall called adiabatic. That means it can't allow the flow of heat. Either they are in same temperature or they are having temperature difference between them. Heat will don't flow between them. And if we make a contact between them, another system called C, and the nature of this wall is conducting. After equilibrium is achieved, you will see that if the temperature of A become temperature of C and temperature of B became temperature of C, that you will also found that the temperature of A become temperature of B. But we don't have any direct contact between system A and B, although system A and B achieves equilibrium. But how? That's the zeroth law of thermodynamics saying. If system A and B are in thermal equilibrium with the third system C, then the system A and B are in thermal equilibrium with each other. For an example, let's system A in temperature 5 degrees centigrade, and which one is separated by an adiabatic wall with a system whose temperature is 10 degrees centigrade, and we placed another system at the side of them with the nature of the wall is conducting, and if this system's temperature is, I can say, 15 degrees centigrade, after achieving equilibrium you will see that the system A's temperature is 10 degrees centigrade and system B's temperature is also 10 degrees centigrade, although there have no direct contact between these systems, and this system's temperature also became 10 degrees centigrade. That's the general idea about the zeroth law of thermodynamics. Let's solve some questions on zeroth law of thermodynamics to make our basics strong. Here's the first one. I'm saying that initially body A is having temperature 13 degree, body B having temperature 10 degree, and C 7 degree centigrade. What will happen after achieving equilibrium according to zeroth law? Actually, doing this kind of questions, very first you have to sum all of the given temperature initially, that is 13, 7 and 10, make sum of this and this will become 3, and how many systems are there, divided it by those many systems, and answer become what. And in case of this, the total is 30, and dividing by 3 equal to 10. That means all of these bodies became 10 degrees centigrade after achieving equilibrium according to Zeroth law. So our answer is option C. Question 2. What will happen after achieving equilibrium? That is, body A is temperature 10 degree, B is 20 degree, C is 30 degree, and D is 40 degree. And in this case, our answer will be that sum of 30 plus 10 is 40, and 40 40 80, and 20, that makes 100 degree, and each of these bodies will accumulate the temperature is 100 divided by 4, that is equal to 25 degrees centigrade. That means each of these bodies temperature became 25 degrees centigrade after achieving equilibrium according to Zeroth law. Here we are saying that the temperature of all the bodies become same after achieving equilibrium. But before the Zeroth law come in take place, there was no such thing like temperature. That means if I am saying that system A and system B are in thermal equilibrium, then what is the thing that is equal in both of these systems? The thing is that the average kinetic energy of system A's molecules and average kinetic energy of system B's molecules are same. That means kinetic energy average of A's molecule equal to kinetic energy average of system B's molecule are same, or rather than I can say the temperature of A equal to temperature of B. This thing, temperature is equal in both of these two systems. That means Zeroth law gives the idea about the temperature. Point is here that the Zeroth law first gives the idea of temperature. Means before Zeroth law there were no such things called like temperature. After the Zeroth law we are saying that if two systems are in thermal equilibrium, that means that the two systems temperature are same, and difference in temperature is the reason of heat. Basically heat means the follow of energy. That means heat is way of transmit energy. Another important thing is thermal equilibrium. Thermal equilibrium means if systems states or coordinates that are pressure, volume, temperature, and number of moles, if they remains constant for infinitely long period of time. That's the meaning of thermal equilibrium. There's a other two equilibrium, that is a mechanical equilibrium and chemical equilibrium. And all of this equilibrium, thermal equilibrium, mechanical equilibrium, and chemical equilibrium together is, we are saying, that is thermodynamic equilibrium. When we are saying that is mechanical equilibrium, when the net force on a body is zero or there is no torque acting on the body. And when we are saying that body is in chemical equilibrium, when the net reaction is zero, that means rate of producing the product is equal to rate of producing the substance are equal, then we are saying that the system A and B are in chemical equilibrium. So if a system A and B are in thermal, chemical, and mechanical equilibrium, we are saying that system A and B are in thermodynamic equilibrium.